Hello everyone, welcome to my YouTube channel. So today we'll be looking at an assignment given to us on physics 117. So we'll be plotting the tree graph on this assignment, the tree graph. The first one is the following reading were obtained in an experiment. X in centimeter 2.5, 5.0, 10.0, 20.0, 30.0, 40.0. Already looking at this table is already completed. Now the x in cm is 24.7, 23.5, 21.2, 16.0, 10.7, 5.3, and x prime in centimeter was given as 25.7, 25.2, 22.4, 16.9, 11.2, 5.5. Now, if you observe something on this table, you see that everything was in one decimal place. So if you are starting a practical, or if you are starting a table, or if you are plotting a graph, please, everything should be in one decimal place if the table is starting with one decimal place. So let's dive in as we plot the graph. Question 1a. Plot a graph of x against s and s against s prime using the same axis. Now this is your graph. This is your graph. You're meant to use a green graph sheet when plotting this. You're meant to do what? Use a green graph sheet when plotting this. Now, question 1. A graph of s in centimeter against x and x prime. Now, let's pick a perfect scale for this, looking at our table. Let's pick a perfect scale for this, looking at our table. Let's say the scale is scale. Please don't write on your graph. Don't write on your graph. Let 2 centimeter represent 5 centimeter on s in centimeter axis. The second scale is let 2 centimeter represent 5 centimeter on x and x prime axis. Sister say we should use the same axis. So I've gotten my title, I've gotten my scale. The next thing, I label my graph. Now here will be what? Here will be s in centimeter against s prime, x and against s and s prime. Please get a long meter rule when drawing your line so that it will not be cut and joined. This is the vertical axis and this is the horizontal axis. Please take note. Now let's start. Looking at your table, we'll have, remember our scale was what, 2 centimeters. So each of the bold line is 1 centimeter. The next bold line will be what? 2 centimeter. And our scale was what? 2 centimeter represents 5 centimeter on the S axis. So every 2 centimeter, I'm going to be writing 5 centimeter. This is another bold line. The next bold line will be what? 10. The next two bold line, 15. Next two, 20. Next two, 25. Next two, 30. 35. 40. 45. 50. So you can stop there because looking at our table, it was at 40. So we can stop at 50. You can decide to do till you finish the graph. Now the next one, let 2 centimeter represent 5 centimeter on X and X prime axis. So every 2 centimeter will have what? 5, same with the other one. 10, 20, 5, 10. This will be 15, 20, 25, 30, 35. Looking at our table, the highest figure there is 25.7. So let's stop there. So you can do it till you reach the end. But let's stop there. Now let's start with the graph plotting. When my S, we'll start with 1 so that you not get confused. So the first one you start with is S against X. The second one will be S against X prime. Is that okay? So let's start with S against X. So this is the full graph. Till the end. So let's start from the bottom. When my S is at 2.5, so if this is 5 and this is 10, each of my two first box will be what? This is how to read your scale. So you need to pick a suitable scale to enable you read every boxes. So each of my two first boxes, permit me to do this. My first two small box will be what? That means it's 1. The next two small box will be 2. The next two boxes will be 3. The next boxes will be 4. And this will be 5. Hope you understand. So same thing here. Next two boxes will be 6. Next two box 7. Next two box 8. Next two box 9. And the other one 10. So if I'm using 2.5, so my 2.5, that's my 2.5. The bold line, this is 2.5. Please don't do all this on your graph. Just making sure you guys see it well and see it very clear. So this is 2.5. So 2.5 on x-axis, this x-axis, and that's your what? 2.5 there. So what was my S? 24.7. So the same thing will be applicable here. So this will be 21, first two box 21, the next two box 22, the next two box 23, the next two box 24. So where will be my 24.7? So that's 24. Let me assume 24.7 will be inside from here to here. So let me just pick the middle as 24.7. So therefore I trace it up here. I trace it up here. Please don't trace it when plotting your graph. I'm doing it so for visibility. I trace it up here and I trace it here. Please don't trace it when plotting your graph. The only thing you are meant to trace is when finding your slope. So I pick here, I star it. Always star it for visibility. So what's the next one? The next one is 5 to 23.5. 5 to 23.5. So this is 5 boldly written here. 23.5 will be here. This is 23. So let me say 23.5. It will be in the middle of the small line between 23 and 24. That's 23.5. So I pick it up and I dot it here. Dot, 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 dot down. Dot, 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 dot up. So the same process till you reach, you find the point, plotted point for all of them. Let's continue. For 10, we have this. This is 10. And under 10, we have 21.2. So this is 21 point. This is 21. So this is 10. So let me just pick the ransom number, which is 21. The next one is 20. 20 is 16 points. So the next two bold line after 15 will be what? 16. So we trace it up and we look for 20 here. This is 20. We trace it up. Please be very careful so you don't make mistake. This is it here. So we do it here. Hope you are understanding. So the next one is 30. This is 30 right here. This is 30. Then we'll move it down towards 10.7. This is 10. The next two line is 11. Sorry, this is 10. The next two line is what? 11. So anything in between here is 10.7. So I decide to pick, let me pick the middle. So I trace it up, or trace it up, or keep tracing. Or trace it up, keep tracing. And I've seen my 30, this is my 30, and this is it here. So I pick here. Please be careful. If possible, use a transparent meter rule. It will help you when doing this, guys. So the last one is 40 under 3 point, sorry, 5.3. So this is 5. The next bold line is 6. The next two bold line, this is 5. The next two bold line is what? 6. So let me assume, or let me pick from the middle. So if I'm picking from the middle, or have this. So yeah, here it is. I'm done plotting my first graph. I'm done plotting my first graph. So I'll pick it and I'll roll it straight. This is perfect. This is perfect. And that's the first one. You do the same thing with the second one, and you have something like this. You have something like this. Okay, let's go through the second one. I'll just do 3 to 2 points. For S prime, you still have 2.5, but for S prime is what? 25.7. So this is 25, this is 26, this is 25, this is 26. So 25.7, 2.5. Starting from here. Let me use another shade of pen or color of pen. We have this. This is black. Let me change it to red. This is red. So the next one is 525.3. 525.3. This 5, this 25. So the same thing you do till the end. So let me just pick my ruler. Let me assume that it's passing like this. Please take note. Do it till the end. Don't assume like me. Now, this is how your graph will look like. The next question is the point of intersection of the two graphs. The point of intersection of the two graphs. Look at my own. I'm assuming that it intersects in 30. Please make sure you know your intersection. It must not be the same with mine. So therefore, I'll be writing on the graph, but don't write anything on the graph. So therefore, the point of my intersection is point of my intersection will be 30.0 30.0 cm. Point of. So after getting this, the question was asked the value of s when x is equal to 0 and s prime is equal to 0. Let's look at something. Now, if you check this graph, this is when x and s prime is equal to what? 0. Now they are asking for the value of what? S. So when 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 s is equal to 0, my x is equal to my s is equal to, let's look at our graph. My s is equal to my s is equal to 25.0. So it will be 25. It will be 25.0 when s prime is equal to 0. My s will be equal to, when s prime is equal to 0, my s will be equal to what? 20. Let me assume this is 26, 27, 28. So let me say it's 28.0. So that's how to get that answer for that. So we'll be looking at question number 3 for group A. Question number 3. The following reading we obtain in an experiment. H in centimeter 7.0, 18.0, 25.0, 45.0, 61.0, 84.0. We're giving small t in second 36.0, 35.6, 35.1, 34.3, 33.3, 33.1, 31.6. Now, let's say make a table of t square and h where t is equal to small t all over 10. 10 is the number of oscillation. Plot a graph of t square against h. Determine the intercept on the t square axis and the slope of the graph. Write down the linear relationship between t square and t. Let's dive in. First of all, let's complete that table. This is for h. is equal to cm, bracket close. We have 7.0, 18.0, 25.0, 61.0, 84.0. Please make sure you use ruler so that your line will be what? Accurate. So this is for t, small letter t, which was given. We'll be looking for this one, t all over 10, t in second, and we'll square this, t square s square. So we have this already given to us, 36.0, 35.6, 35.1, 34.3, 33.1, 31.6. And the next one is what? This t here, we divide it by 10. If we divide this t by 10, we'll be having 3.6. Remember, I told you guys it should be on one decimal place if you started with one decimal place. So if you are filling this table, everything should be in one decimal place. Normally, you're supposed to have 3.60, but leave it in what? One decimal place, because you have started with what? One decimal place. So this will be 3.6. If I approximate this guy here, I'll have 6. This will be 3.5. You remove the 1. This will be 3.4. This will be 3.3. And this will be 3.2. So the next one, we square both sides. If I square 3.6, I'll have 12.9. Here I'll have 12.7. I'll have 12.3. I'll have 11.8. I'll have 11.0. I'll have 10.0. So we have completed that table. The table alone carry a lot of mark when doing this assignment. Now, this is M4 experiment. This is an M4 experiment. So the next thing that was asked here is plot a graph of t square against h. Now you have gotten the value for t square and h was already given to you. So you plot a graph of this t square, where your t square will be in the what? Vertical axis, and your h will be in the horizontal axis. So we should determine the intercept in t square axis. So anything we are having, the intercept to be here. The intercept to be here. When plotting the graph, we'll see that. And write the linear equation between t square and h square. So let's say the equation is equal to t is equal to 2 pi square root of capital letter H, small letter h, all over g. So how do we make this linear? Remember, you're plotting a graph of t square against h. So you make t square subject of formula. So this t square is equal to, we square both sides. We'll have t square is equal to, this square here will cancel this square root, but it will affect this 2. So we have 4 pi square, bracket open, h minus small letter h, bracket close, all over what? G. All over g. So therefore, we'll have, let's open up this bracket. We'll have t square is equal to 4 pi square h minus 4 pi square small letter h all over g and all over g. Now looking at this guy, it was a graph of t square against h. So we need to carry this guy to this place to look like the general graph equation y is equal to mx plus c. So your x is supposed to be here. So therefore my t square is equal to what? Minus 4 pi square small h all over g plus, we move this guy here, and we have 4 pi square capital letter h all over what? G. Now looking at this, we can therefore say that our y is equal to minus m. The minus m is all this equation here, x, which is here, plus c. Your c is everything here. So therefore, the nature of this graph will look like this. The nature of this graph will look like this, where here is what? T square in second square against what? Against h in centimeter. So therefore, I'll be having something like this. I'll be having something like this as my. So this is the nature of this equation here. This equation here. This equation here. This is the nature of this equation. So therefore, I'll be having something like this. And my slope will be like this. So let's dive in plotting the graph. Now the next question in number 3 was plot a graph of t square against h. Determine the intercept on t square axis and the slope of the graph. This is our graph. We have gotten the table. We have transformed the equation. Now let's plot our graph. Question number 3. A graph of t square in second square against h in centimeter. Now, you all know that our vertical axis is what? T square second square. And our horizontal is what? H in centimeter. So let's pick our ruler and let's draw a straight line to form our vertical and horizontal axis. So that's a straight line there. Now, this is our horizontal axis. That's another straight line. And this will be what? This will be 0.0 to show your what? To show your origin. Very important. To show your origin. Now what will be our scale so that we can work on this? Looking at our table, this is our table. What's the suitable scale we can use? Let's look at the value. The highest value of t square is 12. Now let's scale our graph. So we have scale. Let 1 centimeter represent 1 unit. But instead of putting unit, we'll put second square because that's the unit of our quantity on vertical axis, on t square second square axis. Let 10 centimeter, because it's very big, you can see the last value, 10 centimeter represents no, sorry, let 1 centimeter, let 1 centimeter, 1 centimeter represents 10 centimeter on h in centimeter axis. Why are we doing 10 centimeter? Because the value is very big. So that's our scale, which you write at the bottom end of your graph. Now we have scaled this guy. Let's write it here. Let's transform it here. We say that for the vertical axis, we have 1 centimeter represents 1. So this will be 1, every 1 centimeter, 2. So I'm doing this. I'm going to plot a graph now. So I say when my h is at 7.0, this is my h. Don't get confused. My t square will be at what? 12.9. My t square will be at 12.9. T square is 12. This is 12. This will be 12.9. And this is 7. This will be 7. This will be 7. So 12.97. Let me assume is here. But please, when you are choosing your scale, it should be 2 centimeter represents 10 centimeter, so that you'll be able to read this. For me, I can read this. So therefore, the next one will be what? The next one will be 12 here, 12.7, 18. So this is 18. This is 18. And this is 12.7. The next one is what? 12.3, 25. This is 20, this will be 25, 12.3. The next one is 11.8, 45. So this 11.8, 45. So this will be 45. So this is 61, 11.0, 11.0, 61 will be and the last one 84. So this is 84 and this is 10 points. So this is 10 points. This 84. So I told you that the nature of your graph will look like this, which you can see now. It's looking like that. So let's show a best fit graph. So now, how do I get my slope? I'll pick from here. Please use a ruler or meter rule. I'll pick from here. I'll dot it down. Please, this dot is very important. A chain line. So I'll give a chain line down to the end. And I'll give another chain line where it's cutting down to the end. Please use your ruler. And I'll give another chain line. And I'll give another chain line down to chain line. So that's how I'll pick my slope. So my slope will be what? Change in slope, which is my m, is equal to what? My slope will be change in t square against change in h. My change in t square here is h2 minus t2 minus t square 2 minus t square 1 all over h1 minus h2, because this is reverse. It's supposed to be h2 minus h1, but this is reverse, so you are going to add a negative slope. So what will be my t square 2? My t square 2 is, let me assume, is 12.4. So 12.4 minus, let me assume this is 10.8 or 10.9, let me use 9, divided by, this is 20 minus 60. If you check your line well, please, you must not have the same slope as mine. Don't copy and paste. Try this yourself. So therefore we have what? We have, if we use our calculator, we'll have, so after punching our calculator, we'll have this minus this will be this. So this will be equal to 0.00285. So I approximated everything. I'll have is equal to minus 0.030. So that's your slope. Now the last question is number 7. The following reading were obtained in a cooling experiment. Room temperature 30 degrees Celsius. Now they say we should fill in the complete table, plot a graph of L, which is the mean here. You get the mean of L before you plot, against 1 all over F, which is in second. Recall that T is equal to 1 all over F, which is in second. Deduce the velocity. Let's dive in. Now, how do I fill in this table? 1 divided by 341.0 will give us 0.0029. So what are you going to do? You approximate that guy, or you put it in standard form. So it will be 2.9 times 10 raised to power minus 3. 5.0 plus 24.5 plus 24.5 is equal to, you have your answer, divided by 3. You have the mean here. You apply that in everything here. At the end of everything you do, this is how your results will look like. So let's continue. Now you have to plot a graph of what? L against 1 over F. Now this graph can be a little bit confusing. Let's dive in as we plot this graph. Seven. A graph of L in centimeter against 1 all over F in second. So this is how my graph will be. Now the equation for this graph, every graph must have an equation. The equation for this graph is given as, which you need to research, but I'm happy you're watching this video. So therefore, L is equal to V all over 4F minus C. This is the equation for plotting this graph. Now let me see how the nature of the graph will look like. Please don't write on your graph. So therefore my L is equal to, it was the graph of what? L against what? 1 all over F. So I'm bringing out my 1 all over F. This will be V all over 4 dot 1 all over F. You see, this is the same thing as this, minus C. Can we say this is looking like Y is equal to M X minus C? Yes, it's looking like that. So we can get how this graph will look like. So this graph will look like this, passing through the negative intercept.